All right, good morning, and thank you, all of you, for joining us for this session in our Enabling Canadian Innovation Virtual Launch Conference. We're joined today by Sarah Mills, Director of Sales for Central Canada here at CAD Micro, and Harpreet Matharu, Senior Application Specialist and one of our 3D experience experts here at CAD Micro. Today, they're going to take us through what CAD design in the cloud really looks like with the 3D experience platform. Okay, without further ado, I will pass things over to Sarah to get us started.
Hi, everyone. Thank you so much, Jessica, and thanks everyone for joining us. The goal of our session today is for us to give you a quick high-level overview of the platform. Then we'll be looking at the design apps in more detail with a technical review from Harpreet, and then we can move on to any questions that you might have for us when we're done. So let's get started. What the heck is this 3D experience platform anyway? Well, it's a business platform, so it's not just for design. It was actually launched in 2012 by Dassault Systems and started with the CATIA CAD tool. Then the idea was, how do we connect our Solidworks community to share in the power and the breadth of the platform? We're not out to change everything that you do or reinvent the wheel, but we are out to enhance and increase your current processes. The platform is a way to connect everyone in a company or your value chain to one central space or single source of truth. This is for better collaboration regardless of your role, your responsibility, or your geographical location. So basically, the platform is a series of app, services, and content. It connects everyone, like we said, to the innovation process, where you can collaborate and share ideas, store and share files securely, and make better data-driven decisions. And I think if you guys remember back in 2018 or 2019, the expression was big data, big data. And now I feel like in 2020, it's, I think you're on mute, or can you see my screen? One of my customers actually said to me during a meeting that we had probably about a month ago, why should I care about the cloud? Well, there's a couple of different reasons. I mean, Google, Gmail, Facebook, these are the most common examples of cloud computing, which a lot of people are using and probably not even aware that it's actually a cloud platform. But the number one reason we think you should maybe look into cloud computing for your business is to keep your costs down. So there's an a la carte menu of roles and apps that are available, which enable you to only pay for the features that you need, the storage you need based on the number of users and their specific role or job function. There's also no need for expensive servers, laborious version updates or upgrades, which I'm sure we've all been through together. The platform actually updates automatically and you're notified of upcoming upgrades via email. The next reason, which some of you might not love so much, is increased mobility. So you can basically connect to the cloud wherever you are. So if you snuck out to Home Depot on your lunch or Sobeys and your boss calls you, yes, you can actually connect into the cloud and complete your tasks if there's an internet connection. The ability to scale is also huge and very easy if you're using the cloud. This way you can basically just add additional storage space or roles or apps, depending on what your business requires at the time. Another one that we feel is super important is backup and disaster recovery. If your business is using cloud for storing its data, you would most likely not need to keep a huge backup of your stored data. If it's stored on the cloud, as long as you have an internet connection, you'll be able to access it. Another one is increased security, which is also super important. If your data is stored on the cloud, in case of theft in your office, you can actually delete any confidential information or transfer it. And generally, the security of the cloud is very strong and more difficult to breach. So it looks like we're just going to take a quick poll to actually see who in our audience today is already using cloud platforms, or if there's any initiatives that are being worked on right now.
We'll just give you guys a couple of seconds to throw your answers in there. You know, when talking about cloud applications, we don't always immediately go to SharePoint and OneDrive and Microsoft Office, but interested to see what the audience says here. So we'll just leave it up for a couple more seconds. All right, let's see. Okay, so yep, as expected, it looks like the vast majority of you guys are already using some sort of cloud-based application. So we'll go ahead. We've got one more question for you to follow up on that one. Oops. Sorry about that. There we go. So whether you are currently using any cloud-based applications or not, are there any plans at your organization to start implementing them in the future, whether that's for a data management solution, CAD design, or any other requirements. Just leave it for a few more seconds here. All right. Okay, and it's looking like almost a pretty even split, but it does look like a good portion of you guys are planning sometime in the near future to start taking some of your operations to the cloud.
Great. Thanks, Jess. So the platform is actually broken into 5 domains. There's design and engineering, simulation, manufacturing and production, governance, and marketing and sales. But today we're going to hang out in the design and engineering domain, where obviously all the cool kids are hanging out, and focus on the 3 main design apps, which are 3D Sculptor, 3D Creator, and 3D Pattern Shape Creator. So 3D Sculptor actually includes the X-Shape app, and it's a browser-based freeform modeling tool used to create organic shapes using sub-D modeling. So this allows you to quickly create complex organic 3D models. And because 3D Sculptor is so easy to learn and use, you can start with a 3D shape or 2D surface and easily push, pull, scale, crease, bend, whatever you want to do to your sub-D model to get you the shape that you desire. Very similar to modeling clay, but on a computer. 3D Creator, which includes the XDesign app, is a browser-based parametric modeling tool used to create 3D parts and assemblies. This allows users to create those 3D parts and assemblies just like any other parametric modeling tool, but on your browser. 3D Pattern Shape Creator, this is one I think Harpreet really loves. And if you guys see this, what I call CAD Micro Theater in the round, Harpreet actually created this. And he was sending me images last week when we were putting together our presentation with, wow, beautiful, love this. So this is actually a rule-based program that uses complex lifelike geometric patterns, but it's run in your browser. So I'm going to turn it over to Harpreet so he can take you through how these all integrate together to create better designs. Harpreet?
Thank you, Sarah. Now we are going to go ahead and log in into our 3D Experience platform. So I'm going to enter my credentials here, and it's going to take me into the platform. As soon as I go into the platform, it's going to take me to this app called 3D Dashboard. This is a default app that's open at all times. And in this app, what you have is essentially a set of tabs. And in each tab, you have a set of apps that have been placed according to your layout. So right now I have my X-Shape, XDesign, and XGenerative Design, as well as my bookmark editor placed. And this layout was something that I had custom built myself. Now I'm just going to go ahead and drag and drop and open up my first file that we'll be working with in X-Shape. And what I have here is the scan of a patient's leg. And what we are going to do first is we are going to create a form that is going to be a representative of this leg. And then we are going to add more detail on top of it by going into the other programs. Now, when I start creating the representative shape of this leg, I can't just go ahead and start creating it in XDesign or software like a parametric modeling program. The reason being because if I work with a parametric modeling, this leg has such organic curves and shapes that I can't just capture it using parametric modeling. So I'm going to use subdivision modeling instead. So first I'm going to go ahead and place my my quad ball here, which is going to be my initial sub-D model, and I'm going to play with it just like as Sarah said, it's like playing with the clay. So that's what I'm going to do with it, and further shape it so that it looks exactly like this leg. So first, what I'm going to do is I'm going to go ahead and place it in the right location, so somewhere around here, and then I'm going to just select and choose points and just resize this whole shape. So I'm going to shape this part first, then I'm going to take this part and shape this one, and maybe I'm going to flex this a little bit to the right. So I'm going to select my points here like this one. I'm going to choose my flex option and I'm going to flex it in this direction. So I'm going to add my axis here and add my other axis around here, and then we are going to shape it something like this. Maybe I'll put it around here, and I'm going to do it about here. So it kind of looks nicer this way. Now what I'm going to do is I'm going to select these points again, And I'm going to just push it down a little bit and this way so that it looks even better. Now let's see how it looks like from the other side. Okay, it looks kind of nice. And let me also reshape these points so that it's expanded a little bit like that. Just a little bit to the side. And a little bit to this way. Okay, so now we have a bit of our precursor shape that takes over the upper part of the leg. So now what I'm going to do is I'm going to create the foot as well, and then we will start adding more shape to it. So I'm going to take this shape and let's choose 1, 2, 3 of these guys. And there you go, it's done. I'm going to exit my extrude tool. And let me go ahead and just extend it like that. Now these were the ones that I did not need, but they come in anyway. So I'm going to just select them one by one and just going to push them back in. Yes, just like that. And again, I'm going to select these guys, bring them out a little more so that it looks nice. So it kind of shapes the same shape as my foot. All right, so that looks better. A little bit to the side, a little bit to the back. Okay, that looks better too. And I think it looks nice now. I think it looks nice. Let me also take this out a little bit. Oh, look at that. That's perfect. All right. So now what I'm going to do is I'm going to add, let me also shade this up a little bit too so that it looks even better. Yes, that looks relatively better. I just looking to add some smoothness to it right now. It looks fairly smooth, so let's add more definition to it. So first thing first, what I'm going to do is let me make this transparent. Okay, so that we see the inside detail that we have to capture. Now what I'm going to do is I'm going to choose all of my faces at the top. And then I'm going to crease them. What crease is going to do is it's going to separate those faces out. And then I can easily work with them. So let me choose these guys. And I'm going to align entities by line. And I'm going to align them somewhere around here. Perfect. Similarly, let me choose these ones. Any entities, let me choose these guys. And I'm going to choose these lines. And let me align them around here. Similarly, I could choose the ones at the bottom as well, but I don't want to take too much detail out of there at first. Let me just I would like to move these points to the side a little bit. So I'm going to select them like this, scrunch them in a little bit, and then move to the right, like that. Okay, so that is looking way better now. All right, so once this is done, I'm also going to choose these points and move them down a notch. Perfect. That is looking way better now. Okay, so now what I'm going to do is to add more detail, I'm going to add more loops to it. So I'm going to go here, add a few loops here. Maybe I'll add one around there. And another one around there. And as I keep going down, I'll add more and more loops. So I want another one around here. And another one about here. So it's just a guesswork right now making. And maybe I'll add, no, maybe that's too far right now. Okay, I'll think about it afterwards how I'm going to deal with this. let me just think about it right now. So we go here, align entities by line, and I'm going to align them like that. Perfect. Once these are done, I'm going to choose this one, align entities by line, and I'm going to align like that. Similarly, I'm going to choose these ones now. I'm gonna have to redo this one. Okay, so something like this. Perfect. And then I won't worry too much about that part yet. Perfect. It's nicely following the shape right now, and to be honest, I feel like I may not even need this loop, but let's see. Let's see how things are going to go. Oh, maybe I will. Maybe I will. I think it's looking very nice right now around here. Coming along very nicely. Now I'm going to choose these ones now again. Align line entities. Perfect. Looking very nice now. So now I just need to align it from here. Somewhere around like that. And something like this. And these ones, I'm just going to move them somewhere like that. And I'm going to move these ones like that. And finally, we have this final nut around there. Okay, so it's looking pretty nice so far. It's going to do one more here. Okay, this is looking pretty good now. Let me select one of the edges this time. And I'll just bring that one out. And then that edge. And we bring that one out. And just like that, we are able to cover the top leg. Similarly, I'm going to bring that one out. And let me also bring the vertex out. There you go. So just like that, I can keep adding more and more detail. I would do the similar part with the foot as well. But quickly, I just want to show you another part where about how to add the detail for the ankle, because we have covered the leg. We have also have a basic shape for the foot that can also be further improved. But I just want to add some detail for my ankle like that. So for that, I'm going to subdivide my surface. And then once I've subdivided it, I'm just going to choose my base here, and then that is going to help me add more detail for my ankle. just like that. And then I'm also going to take these ones as well and just rotate up a little bit and bring them outside. And just like that, I have added the detail for the ankle. Similarly, you will keep going. Now I have a little bit of detail, but I would definitely need to bring this inwards a little bit, like that. And then my detail for my ankle has been added. Similarly, I'll keep working with my heel as well as the toe, and I will keep adding more and more detail. Now that I have shown you how this would be done, let's assume that I could do the rest of the work. So it takes about an hour to 40 minutes to complete this, to capture all the detail. Now I will just go ahead and save and close this model, and we will open up a completed model that I had created similar to this one. I'm not going to, actually, let me just save it. So I'm opening up in an XDesign now. Okay, so this is a model that I have previously created on my own. So now what we're going to do is we're going to add more detail to this one, and we're going to create a brace out of it. So right now I have opened up this model in XDesign, which is a parametric modeling tool. And now I'm going to start creating and adding more detail to it. So the way we're going to start is we're first going to remove some of the material at the top. And because that material is going to be the one, because as you're creating the brace, we will not want the brace to have the same shape as the toe at the front. We will just want it a circular base. So that's what we're going to do here. So I'm going to go create a sketch on my base plane here. And then I'm just going to go ahead and create some sort of arc like that. That is going to cut away material. Let's say we're going to remove that much material. And now what I'm going to do is I'm going to go under my features, and I'm going to start extrude cut. And this is a point that I would like to emphasize on. As I open up my extrude, all of the commands such as extrude boss, extrude cut, they are combined into one. The idea in XDesign is that the user experience is dramatically enhanced. And the enhancement is partly being communicated or being shown to you by combining some of the often used features, some frequently used features. So one of the ones that are often combined are extrude cut and extrude boss. And same for boss and cut features. They're often worked with together. So that's why those features have been combined into ones. I can either go with add and create an extrude cut, extrude boss, or I can do extrude cut. I can also create an extrude surface right here as well. So all of these commands have been combined into ones. So right now what I'm going to do is extrude cut, and it's going to create a cut for me. Another thing I want to emphasize is that along with the extrude, there is a drop-down menu at the top that lets me combine and change between revolve and sweep feature. It's the same kind of option that you have seen in Solidworks, where you can switch between fillet and chamfer tool. You will also see the similar behavior in the patterning tool in XDesign as well. So the idea behind this is that it will give you enhanced experience. That's the whole idea behind it. And all of these features are not just regular features, they are called super features because they can be distinguished between. So now that they can be combined. So now that I have removed the material at the bottom, now I'm going to remove a little bit from the side, and that will give us the shape of my design. So let's go ahead and start. So I'm going to start my sketch on the side plane like that. And what I'm going to do is I have a plane here. I'm going to use that as a reference geometry. So first let me go here, and I'm just going to create my base shape, and then afterwards I'll add more detail to it. Okay, so we have our base shape here. And now what I'm going to do is I'm going to add some information. This is about 170, and this is about 300, and this line is coincident or parallel to that plane. So actually, let's take this line then. So this line and that line are parallel. And also there is a distance of about 10 millimeters. And this is about 130. This line is at an angle of 103. And then what we're going to do is we're going to apply fillet here. So I'm going to choose, just drag and drop across any segments that are connecting each other, and that will create fillet for me. And this fillet is about 15. And then I'm going to give it the dimensions. So the dimensions are between these two lines. It's about 60 between this and that line. It's about 80, and finally between this point and that point, it's about 250. Okay, we probably went too much. I'll reduce it a notch. I'll make it 170. So now we're going to give it the shape. So we're going to go ahead and I'm going to click OK here. And I'm going to go under Features again. And I'm going to start my extrude. This time again, we're going to choose the Surface Cut tool. We're going to do through all both ways, and we're going to do it to the top so that the material at the top is removed. So now that this is removed, we can go ahead and add more. We can convert it into a shell and perform more operations on it. So I'm going to go ahead and activate my shell command, tangent propagation, and I'm going to do the opposite way. Okay, so the tangent is not working. What I'm going to do is I think I have some geometry that has a very high radius of curvature that is causing an issue. I'm going to cut somewhere around here, and hopefully that will help. Okay, so it was working. Let's go back, and I'm going to click here, and this time it did convert it into a shell, and I'm going to convert it into a shell. Now we can go ahead and remove some of the material that is not required here, and we can perform some more operation on it. But we have the overall basic shape of the shell on our hands. And now I'm going to just close this, and I'm going to show you how my final device look like after I perform more operations on it. So let me go ahead and open this one. And that will open up the device that I had finished on my end. And there it is. I have removed some of the material at the top so that it's completely flat. And I'll also add some reinforcement around the Achilles tendon as well, just to demonstrate that you can also have non-uniform thickness, and you can do so by surface modeling. So let me close this, and now we're going to move into our next tool. This is the coolest tool out of all of this, which is XGenerative Design. XGenerative Design is a very, very, very powerful software. What it allows you to do, it allows you to perform, to create visual programming of the task of the features, and you can create very complex geometrical patterns out of it. So what we are going to do now next is we're going to create perforation on this whole device. So now we have the whole device created, and instead of having to create perforation on the whole thing, which is going to be very difficult, we are going to create a program that is going to be able to convert this. So for that, I'm going to open up my design sequence here. And what this allows me to do is it allows me to create a program that will be able to convert and add perforations on it. So to do that, what I'm going to do first is I'm going to create an input geometry. And that's going to be my input geometry. Once the input has been given, I'm going to search for the sub-elements. And the dimension is going to be faces. And then I'm going to group them by continuity. And then I will get a few items out of here, and I can select and see which one is the one that I'm looking for. Okay, so looks like it's the second one I'm looking at. So I'm gonna say get item, and we're going to get the item number 2. Let me confirm again that is indeed the one I'm looking at. Yes, that's the outer surface. So now I have the outer surface on my hand, and what I'm going to do is I'm going to distribute holes on it. But before I distribute holes, I want to do something else. I don't want to distribute holes out of the everywhere so that even around here I have holes. So I want it at a little bit of an offset. So what I'm going to do is I'm going to create a boundary. And then I'm going to create a curve parallel, which is going to be a boundary on the same tool, on the same surface, but it's going to be at an offset of some value. And I'm also going to drag this out so that I have a bit of a control on it. Let's say it's about 10 millimeters, and I can see my offset on the side. The next thing what I'm going to do is I'm going to go ahead and create I'm going to add, let's say, I'm going to add a slice surface. So I'm going to slice the surface, slice the initial one that we had gotten, and we're going to slice it using this curve. And let's see which one is the inner curve. So that one is the outside, this one is the inner, and that's the one we're looking for, as you can see. And now we're going to distribute holes on it. So distribute holes, let me actually first get the item. So it's the second item we are looking at. And next, what we're going to do is we are going to distribute points on it. So to do that, I'm going to choose my surface sampling tool, and I'm going to connect it to the surface, and then I'm going to take the number of points out, and so that I have a separate control on it. Maybe I'll go with 50 points right now, or maybe let's even go higher, 100 points. So as you can see, it has distributed all of these points on top of it. And we can increase it, and that will control how many points are going to be there. And now let's go ahead and do some more operations. I'm going to create lines on top of this. So the next thing I'm going to do is I'm going to create a line on all of these points that are going to be at as normal to this surface. Oh, not this one. It's going to be, these are the points, and that is my surface. So it has created those lines, and now using these lines, we're going to create plane normal. So it's going to be, these are the lines, and these are the points. and it has also created the planes as well. Now for each of these points as well as the plane, we're going to place circles and we're going to create extrude holes. So I'm going to create circles, circle center radius, and the centers are located using this surface points, and the support are these planes. Let me also hide some of the detail as well now. Now that I have too many of this, it would be a good idea to hide some of these things here. Okay. So now what I'm going to do next is I'm going to take my radius out, and 10 millimeters is probably too high, so I'm going to make it 1. And next thing what we are going to do is I'm going to create a fill surface for these ones. What that is going to do is it's going to fill all of these circles, and then we're going to thicken it. And then we'll have rods coming out of here that we will use to remove the material. Let me add 2 here and about 2 here. And if I go closer, you can see it has created material like that. And now we're going to use that to remove holes from our final geometry. So I'm going to use remove command, and our volume, the first volume is this one, the knit surface. So what I'm going to do is, because it's so far away, can't really go from there and connect it. So I'm going to click on it and I'm going to make it stars so that it becomes one of my major inputs, which I can access from anywhere I want. So I can right click here, and I'm going to click here and then input 1. And then I'm going to connect here. And that's going to remove my material. Let me also remove and hide all of these objects as well, so it's easier to see. And I'm also going to hide my main object on in here so that it's easier to see what's going on. Oh, no, I think I made a mistake here. What I need to do is I need to add all of these first into one object. Because there are multiple objects, it's not really working that way. So I'll need to have these as separate objects. Only then it would work. There you go. So now we have holes in this object. And now what I can do is, because it's all a visual programming here, I can control it from here itself. I can say it's 2 millimeters, and instead of 100 holes, let's distribute 500 holes randomly. And I also have the ability to control the size of these holes as well, but I won't go into it at this point. And then it's going to refresh. And it's a pretty robust tool that can refresh very quickly as well. So all of these things are what make this tool extremely, extremely powerful. And now you can see it has added all this information. And now if you wanted to go further, you can do another thing. You can go ahead and extrude that surface that we were using before. So the one that we had previously. So when we had sliced, I can go here and say, hey, get item again on this. It was just something that I thought about it just now. And I can say that add a thickness to the surface, and add maybe a thickness of about 2 millimeters perhaps. And let's see if it works. There you go. And I didn't add it in the direction I was envisioning, so let's make it do in the other direction. Hopefully it will work. No, there are some issues with the geometry. No, it worked. Okay, there you go. There you go. It added a boundary around this as well. So this is the power of this program. I'll be happy to take any questions if you want after Sarah's presentation. So I'm going to hand it over to Sarah now, and we'll go from there. Thank you.
Thanks, Harpreet. Make sure that I pull my screen back up here, guys. So there's a couple of products that we just didn't have time to cover today, but we felt deserved an honorable mention or a big shout out, as we say at CAD Micro, which is the 3D sheet metal creator, which is pretty much exactly what it sounds like. It allows you to create accurate, detailed sheet metal designs ready for manufacturing. So this role is basically tailored to the needs of the sheet metal designers and engineers who need to design sheet metal components and enclosures. Then there's the 3D render tool, which is one of my favorites, actually. It's a cloud-based rendering app that lets you create photorealistic images directly in your browser. So we've been tasked by some of our customers to bring to the table some better 3D tools to help them create customer-facing presentations. So if you're using the cloud platform, this is definitely a tool that we would recommend to get photorealistic images for your marketing materials and to win bids also. So basically, we're done our technical portion of the presentation, but as you guys can see, these browser-based modeling tools that we previewed today allow you to make better modeling decisions. You can create amazing organic shapes and have more control over your design tools to bring your concepts and your ideas to life. So we really appreciate you guys joining us. We're going to take some time for some questions now, which I think we had quite a few come in during Harpreet's presentation.
Perfect. Thank you so much, Sarah. That was great. Thanks, Sarah and Harpreet. We do have some time left for some questions, and we do have quite a few in the queue already. So I think we will go ahead and get started, but you can keep your questions coming if you haven't gotten them in just yet. Harpreet, first question is for you. The question is, how does designing on the cloud compare to designing on a desktop version of SolidWorks? When would it be better to use SolidWorks versus the design apps on the cloud?
Okay, I think that's a pretty good question. It all depends on what your requirements are. Currently, as XDesign is created, it's mostly towards the user who are using parametric modeling to create basic set of features, to use basic set of features to create your models. So if you're looking to create something such as weldments or more complicated geometries, then SolidWorks would be your better option. But if you are using your regular solid features or your surface modeling, then XDesign would be a pretty good tool for you.
Great, thank you, Harpreet. Another question for you here. What if I've already started designing a model in desktop SolidWorks? Can I move it over to the cloud to use the design apps?
Yes, you can. So there are two ways that you can go about it. One of them is that you will import your geometry in. So it won't, the only thing is it won't bring in any features that you have added. So there are two ways that you can go from there once you have brought in your geometry. Either you can add more feature on top of it using XDesign, or another thing you can do is there is a tool in XDesign which is called a feature called Direct Edit, which lets you directly edit the surfaces and play around with them. So you can go either way, but it is possible to bring in and import your files that you have already been working with in SolidWorks.
Okay, great. Another one for you, Harpreet. Actually, there's two similar questions. So questions are, how fast does my internet need to be to use this? And the second part is, what are the computer requirements to be able to run these programs?
That's actually a really good question. So in terms of the speed, I just recently had a really good experience related to that. So we had an internet outage, and I was doing training at that point, and I ended up having to use hotspot on my phone. And not only I used the hotspot for myself, I also used it for my trainees as well. And there were two other trainees. So all of us used the same internet, and we had a upload speed of, I think, about a megabyte per second or something along those lines, and a download speed about 10 megabytes or 15 megabytes per second. So even with that speed, we were able to share with 3 users. So at the end of the day, you won't need that high of a speed. As long as you have decent connection that you can find in the market today, you should be fine. Now, again, related to the computer requirements, things can get a little tricky there. You can, because everything is working on the cloud, you should be able to use any sort of program and be able to use with it, use these programs with the computer. Now, having said that, if you have, in terms of configuration, if you have decent configuration based on the regular decent configuration that you can find on the market, you should be fine. You won't need as high of requirements as you would for SolidWorks. So now, in conclusion, what I would say about that is, if you buy a machine with a Core i7 processor and anything along those lines, you should be able to do very high level of modeling. If your modeling is not that complicated enough, you can even do it on iPad. So it depends on the level of complexity of your models.
Great, thank you, Harpreet. Sarah, I think this next one is best for you. So the question is, how does the licensing work? Do I buy them all individually?
So basically, it's sort of like an a la carte menu. So you can buy based on your role in the company, and they're quarterly or yearly term licenses.
Perfect, thank you, Sarah. Harpreet, another one for you. What is the benefit of doing this manually as opposed to getting a mesh imported?
So I'm guessing this question was directed at the X-shaped one. So when what you would notice is in that initial model that I had, there was a leg that was already there. That leg was actually a mesh. The reason why I created a subdivided model on top of it, because a mesh at the end of the day, it's just numerical data that represent the triangles or that represent the shape that you have for the model. You can't perform any modeling on top of it with any parametric or even subdividing modeling tool. So to be able to model in a parametric tool where you can create some devices out of it, you will have to do a modeling such as subdivision modeling. So that's why I had to use and create a subdivided model on top of it.
Wonderful, thank you. Harpreet, another one for you. How do support and upgrades work on the cloud?
Actually, that's one of the great benefit of moving to the cloud. The support, because all of these, so first of all, in terms of upgrades, they are all scheduled by the source systems themselves. So they will just send you a notification that this is the time that we are planning to do the upgrade, and then they will upgrade your system before you even know it. So that's one of the benefits, that you don't really have to worry about any of those upgrades. It will be done at the time when you are experiencing when your organization is not using any of the programs, and you would be good to go. Now, in terms of the support, again, support gets very easier too, because in this case, we have all the, even though we are not directly looking into your data, but still any issues that pop up, because they are running on the cloud, it's very easy. It's relatively easier to tackle problems and resolve such issues. So it becomes way better as opposed to working on a desktop and resolving issues and upgrading.
Great, thanks, Harpreet.
Yeah.
Now, we've got a couple of questions that are kind of similar here, so I'm going to read them out to you at once. The first one was, is there training available on the 3D Experience platform? And the next one was, I'm not using SolidWorks right now. How do I learn about all the tools available?
Sorry, can you repeat the second question again?
Yeah, I'm not using SolidWorks right now. How do I learn all the tools available?
Well, there is a learning portal that 3D Experience comes along with, and it gives you the basic information on how to use this software. But at the end of the day, if you ever feel like you wanted to learn more about it, you can always reach out to us, and we can provide you training related to the programs that you're interested in.
Great. Another one, Harpreet. Are all adjustments to the surface done on the standard coordinate surface, or can additional planes be added?
Additional, so okay, so the answer to that is neither, nor no to both of them. It's not that everything is done in the standard coordinate system, and it's not that you can add additional planes. So the way it works is there are three possible options. So let me actually share my screen if that works, and then I think I will be able to explain better. Jessica, can you hand me the screen? Thank you. All right, so I'll need to restart my login here. I think that's a pretty good question, because that actually dictates how you're gonna end up doing the X-shape modeling. So let me open up one of my existing bit once X-shape loads. Okay, I think I'm having an issue with my app, so I'm just going to bring it in here again. So this is also, you're seeing how the layout is generated too. All you need to do is just go into your left side, find the app, open it up, and it gets added to the layout. All right, so let me drop this in here, and then I can show you how it works.
And Harpreet, while that one's loading, if you'd like, I can throw one more question your way.
What is it?
So the next question is, if I wanted to run a simulation on this part, would I have to export it to desktop simulation first?
Not necessarily. You can actually use the existing model, and you can do the simulation in the cloud platform itself. I mean, obviously there would be a desktop version of the simulation software, but you won't necessarily have to export anything.
Great.
Okay. Having said that, so this is the subd model that I'm working in. Let's suppose I need to move this surface, and this robot tool that we were working with, I can right click on it. Then I have these three options. Either I can have it selection, which means that whichever entity that I've selected, it's going to be normal to that. So it's looking at the normal of these plane. Or I can say I want screen. So what that would do is, this is actually very cool. So what it does is, as I move along the line, it always remains, the orientation remains the same. So you're just changing the orientation of the plane, but your robot tool kind of remains the same. So if I wanted to move it in that direction, I can bring it and move it that way. If I move it in this direction, I'll just change the orientation a little bit, and then I can move it this way. And if I choose X, Y, Z, then it's a standard coordinate. So that's what you can do.
Wonderful. Thank you so much, Harpreet. You know what, I think that's all of the questions answered. So I think that's about it for today. Once again, thank you very much to both of our presenters, Sarah and Harpreet. And thank you to all of our attendees for joining us today for this session in our Enabling Canadian Innovation series. So thanks again, everybody. Take care and enjoy the rest of your day.
Thank you.